Today's session will discuss container observability and troubleshooting developer local builds using Osquery. My name is Ody Lupescu. I am from Ethos, and I'll walk you through the kind of mix session that's a demo as well as a presentation. And the agenda really is the two use cases mentioned. We have cases that straddle security and DevOps, and cases that straddles IT and developer productivity. And I'll go first. I'll introduce myself, my role, my background, talk about the problem statement, why these use cases, and then go into the details for each use case. We'll actually do a little hands-on as well, and we'll parallel different options that one may have to take this further. The first case that I mentioned is tracing containers, and specifically the production environment to the developer workstation. The ability to have this end-to-end visibility into what has been built and has ended up in a production environment, or other environments for that matter, such as staging. And the second use case, the troubleshooting performance issues for developers, it's essentially a common problem, and we'll kind of try to get to the bottom of it. So that said, introductions. I mentioned Ody Lupescu. I am currently at Ethos. I look after security, compliance, IT, privacy, a few things, and I've been in security roles for roughly 24 years. The context for today's demonstration and presentation is a modern technology stack. Think of a place with a production workloads that are 100% containerized, running in Kubernetes clusters. In our examples, we'll have EKS in Amazon. We'll have developers that develop things locally, and they build things locally, containers and everything else. And they basically finished locally, and then they go. The process goes through a CI/CD and ends up in production. We'll also have an environment that's we'll assume it's 100% MacBooks, which is a mirror of what we're using today. So this is the initial premise, and let's go into the first use case. The use case came about in our daily operations, where at some point, we have monitoring solutions that will create alerts saying, "Hey, look, there's a new workload. It just showed up in production. It started making some connections. Sometimes it makes outbound connections, and it generates an alert, and someone needs to look at it." And there's a couple of nuances there. First, is it legitimate? It could be malicious, or it could be legitimate. That is. The other thing is, if it ended up in production, did it actually follow the change management processes? If you're subject to SOC 2, you will eventually have to demonstrate that whatever ends up in production followed your change management processes. So in every instance when we get these alerts, it's not the most exciting thing in the world. We have to do a lot of digging. And invariably, it turns out that things are legitimate. But it's not easy to point that out. And if we don't look at it, it may not be legitimate. And we also, for our SOC 2 purposes, we have some responsibility to monitor such alerts. So it's kind of must do, not the most exciting thing in the world, and it's not exciting because it takes a lot of manual interaction. So with systems and individuals. So our experience has been going to Slack, going to our CI/CD pipeline, going to GitHub and many places, and eventually finding the information. We eventually developed some solutions, one Osquery based, and we'll discuss it here, and one that we sort of glued together internally, where we created a dashboard based on data from our GitHub and our CI/CD solutions. The ultimate goal was to make this process more simple and efficient. And let's go into the specific predicament in this case. So we'll have an EKS cluster, and it will have Osquery deployed. Now, a note here: we have Osquery deployed using optics. So we use optics, and you may notice throughout the presentation that there will be parallels between optics and Osquery per se. And I'll point out the potential differences and how things could be approached with a pure Osquery solution. Developer workstations as well in our environment have Osquery deployed. Again, optics. And optics in this case, it functions as a remote Osquery API servers. And it also is a repository of all the previous events. So everything that ever happens, it's basically stored in optics. And we have the ability to query both in time and all the systems, either in real time or in basically the previous events through optics. And for a CLI, we'll use SQL, which is similar to Osquery I, but it's a little different because, again, it's optics specific. So there'll be some differences between what one will do with Osquery per se and one will do with optics. Our presentation will, as I mentioned, will focus based on the solution we have, which is optics, but I'll point out differences along the way. Now, a little more context about our predicament in this use case. As a security person, or the security team for that matter, we don't have access to the production environment. So when we try to gather information from our production environment, we can SSH, and we don't have access to kubectl, so zero. We do have a solution called Lacework, and we have Datadog and some other automation scripts that give us information, but we can't really interact with them. I mean, Lacework we can interact, and Datadog we can interact, but at the end of the day, we don't have something that we can basically say, tell me more, and it will do that. If whatever is there is there. So that's a predicament. We do have access to GitHub, GitHub Action, our registry, and CI/CD environment read-only. So that's what we use before to get information about production workloads. Now, here comes Osquery, and one of the advantages and one of the benefits that we saw with it is we can find additional information and start querying our production workloads. And specifically go into the Docker containers. If you've tried to get information about containers using kubectl describe pod or basically list everything in your namespaces, you'll know that you get some information about the containers, but you don't get too much. You don't nearly get enough to make sense of what's there. And that's one of the things that we noticed. We needed additional information. So there is a specific command. I believe it is part of Osquery at this point. If not, there is a PR that I suspect has gone through that provides this in the base Osquery package. And that is select star from Docker image history. And let me show you how that looks. Again, we're going to use the CLI tool. This is on my laptop. These are the images that I have. I'm connected in real time to my laptop. So this is the equivalent of running Osquery I against my own device. And what I see here when I run the command, it tells me the containers. It tells me their ID, each container having an ID, sort of the signature. When it was created, the size, and then created by. And these are the commands and the sequence of commands that were used to build the container. And this is, again, particularly helpful in more ways than one. And going back to the presentation, I'll kind of spell out a little bit as to why this is very relevant for us. We discovered that containers that we have deployed in our production environment differed. Their signatures were different than the signature of the containers that were built locally. And it was pretty obvious during the CI/CD process. Even though you use the exact same commands, there are additional artifacts that they're added. And invariably, the hash is going to be different. So you can match something that's in production with something that is on a developer workstation based on hash. So we need to look at the build commands. That's one way to figure out what exactly was deployed and perhaps where it came from. So that's for us was very helpful. This set of commands that showed how things were built is equivalent of running Docker images and dive locally. I could run the same thing and I would get the same information. The challenge for us, we can go to our production systems and basically have access to the CLI. So we would never be able to get that information with our access. So once we've done that, and you may have noticed here, the command brings a lot of information, and the structure itself is human readable, but it's not the most friendly way to look at things. Now, there's two ways to do this. You can pipe it to a file, and once you pipe it to a file, you can examine it. If you have optics, on the other hand, and we use optics, we can run the same command, and we can run it. So again, I'll run it against my host, and I can do the same thing, and I will get from Docker image history. Okay, there we go. So we'll be running it, and what we see here is the actual sequence of commands. Now, again, look at a file if you use Osquery or looking at something like this. The idea this is that this is where the science sort of ends. You get this information. Now, can you find out where else the same set of commands may have been used to build the same container? And this is kind of where it's getting, well, yes, there's like 10 different commands. Are you going to search for all the 10 different commands in that particular sequence? The query can get quite complex. And this is where it helps to figure out, is there something more unique about a specific build command? And if you can find something more unique, like for instance, there may be hashes. Like in this case, there was a particular file that was used to build this container. And unless you pick one that's a part of a base container that's going to be everywhere, those tend to be more unique. They would have their own signature. The other thing you basically could have is tags, and some tags could give you an idea of where things may have come from. So then you can search for those specific things, and that will give you more of an idea of where these things came from. And in this case, I can then go against a number of assets, and I'll pick up a production cluster, a development cluster here, and I can run the same command. And running the same command will give me an idea of how many of them are running the same. I'm sorry, now I'm seeing all those images. But going back to my system, we see here that one of the commands that I mentioned is, and it has a tag. We can pick the tag, this tag, so we can see what particular system has the same tag. Okay, where tags equals. There it goes. So if we run this. So we get one row here. Now let's look in our development environment. In this case, I'm using development, but suppose this was something in production, I would run against the production environment. And I want to see, is this somewhere in there? And I find out that it's on one system here. So only one system has the same tag, same container. And that to me, it tells me to some degree that I know with some certainty that this particular container that's now in some environment in, say, production, development, wherever, it came from my particular workstation. I could run this against all of the assets that we have, and I can find out, was this on any other particular developer workstation? So the advantage is the ability to dig into things. And as I said, it's not an exact science. You've got to pick up the things that perhaps make a particular workload more unique, the commands that were used. But this ability to match we did not have before. We had no visibility into this, and for us, it's been very, very helpful and very refreshing in the way we search for production workloads. So again, there's ways to make this a lot better, and I wish we would have gone to that through that exercise. We plan to do at some point. The opportunities for improvement are significant in the sense that I can automate. I can basically have a query that tells me every time there's a new production workload, I can go look and see, well, these were the commands used to build it. Do I have the same thing in the staging environment? Because technically I should. If you came to production, you should have gone through some testing in the staging environment. So I should see the same thing in the staging environment. Again, I can match based on signature because there's different artifacts that will make them completely different. And then I would want to find out which workstation it came from, perhaps one or more. And that's helpful if you do any thread hunting or if you want to have some level of attribution about what happened. So for us, this was this is something that we found useful, and we plan to expand on it to create some scripts, and then go through this exercise whenever something comes up, and point out potentially in advance of any be aware in advance of any potential problems. So proactive compliance, if you want, aside from threat hunting. So that was one example that where we found Osquery particularly helpful. And related to it, we have another example. Now, in this case, it's not, the previous one was more on the security and the DevOps side, where some things ends up in production. Now, the next one is the IT and I want to say developer productivity, or developers per se. And this is a problem that I suspect many are encountering. And we run into it on a common basis. It happens quite often, where we would get someone in the development teams coming and saying, look, the workstation you gave me, unfortunately, some of them have 16 gigs. Not everyone has 32 gigs on their Macs. Nonetheless, they're pretty powerful machines, but they will come back and say, look, it takes me 5 minutes to build something, and I just can't work with this. I started this build, and look, I went and got a coffee, made myself breakfast, and still it's not done. And, I'm tired of it. So invariably that gets blamed on IT. And I'm looking after IT, so ultimately this is my problem. And I've been trying to figure out, well, what's wrong? Why is this happening? And can we use some solution to find out the reason for it? Now, I do have my suspicion that this is not necessarily a hardware problem. I'm not going to say that it's okay, fine, it's their fault. We don't say that, but based on what we learned so far, more often than not, it wasn't that anything was maxed out on their systems at any given time. But we did find instances where the code kept waiting, and it was a problem with the code. And I'm not going to say that we're blaming things on that, but it could be one of the causes, and we've seen it more often than others. So the problem is, how do we figure that out, and how do we help them improve that? If it's a problem with their code, how do they identify what particularly is the problem and fix it? So this is again where Osquery comes in handy. In this context, the environment is similar to the previous one, except now we're focusing primarily on the workstations. We don't have anything Kubernetes or production deployments. So we have workstations with Osquery deployed. We're collecting performance metrics from those workstations. We're using optics, and the same thing with the CLI. Now, one thing that happens for those of you that build things, you know that when you run the command make to build something, this is the beginning of a process, and the command make itself may take 5 minutes to execute, but it's not the make command that it takes 5 minutes. It's the sub processes that are launched they're actually taking the time. And you may have things that wait, and because they're sequential, you may have things that go in parallel. But bottom line is there are lots of child processes. Now, this is where you can, again, use Osquery to get some understanding of what exactly is happening when that command was launched. And there is the advantage of ancestry and the ancestry field, and there's the advantage of having the parent relationship between processes. So I put on the screen a query that provides this. Again, this is in the context of optics. You should be able to do the same thing with Osquery I. Difference here is obviously the way the day is defined, the time period. In this case, there's a UPT day, which you can find the sort of the same in Osquery I in a different format, and then the potential location of the tables. So let me show you how this looks at the command prompt. So the command that we'll run will give us the, I'll select from here, I have already saved it. What this will tell us is the process they're running. It will also tell us a little more information. In this case, it's a join with a different table of system information. And the goal is for us to get as much information about what's running. Now, as with the previous command, if you do it at the CLI, it's best to save it to a file and then look at the file and essentially process it there, visualize it there. In our case, we have optics. We already have it up. I ran the same command. And again, this selects from the process events. It does a join with system info, which is another table. And it does the join on a particular asset and a particular parent process. So I ran in this case, I found all the instances where the command make was run on a particular system. And this is the particular system in this case. And once I found out the command make that was run, I said, I want to see basically the commands that were used, that were child processes of the make command. So here we get to see what exactly this person ran. And you will see invariably the series of commands, they're all tied to a specific make. And for us, the goal is to essentially pick up each one of these processes, each one of those Docker builds. We want to know which one takes perhaps the most time. If we find that at a particular instance of make, the overall time required to complete was long or too long, then our goal is to look at that particular system, look at what the child processes were, and monitor each child process based on the performance data and get an idea of the processor time, memory, potentially disk utilization, and so forth. Now, we ideally want to script this, and we want to make it so that it's basically a dashboard, if nothing else. And the developers will ultimately get to look at the dashboard themselves and say, oh, I know, I was building this and this is taking me forever. Perhaps there's a problem with this particular part of the build. Now, there's a bunch of challenges. Again, you can do joins with different tables, and that's what we worked on doing. Bringing additional information and matching it with what happens with the sub-process level. Again, this is an example from a file that I happen to save locally. Same information, same visualization, and so forth. You can achieve with a CLI versus optics. They both can give you this visual information. Now, ultimately, this is a lot more complex than we initially thought. In other words, there are some challenges in matching specific CPU utilization and other system level considerations with a particular process. You got to match the timestamp. So many things could be running at the same time on a system. And yes, you do get some processor time for something. But you've got to look, it was my processor 100% at the time, but was it because of this or was it because of something else? So you've gotta tease out what's relevant, and there's a lot of information. So what we're working on right now is actually kind of creating this dashboard where you can just go and see everything. It brings everything in. We're not there yet. As I said, it's not trivial, but we believe we'll be able to get this. Once we get it, we'll love to share it. And again, the goal would be go in one place, see what happens during the make command, and hopefully help developer help themselves. So those are the two use cases that we've been pretty excited about. We're still building them, and we're excited about the possibilities. And I'll be happy to answer questions. Thank you.